Bismillahirrahmanirrahim. Doping of semiconductor. Pure silicon is poor conductor of electricity. In order to enhance its conduction characteristics, we add impurities in it, which is called as doping. In simple words, addition of impurities in pure semiconductor is called as doping. There are two types of semiconductors, intrinsic and extrinsic. Pure semiconductor is called as intrinsic. Suppose purified silicon or germanium, etc. When we add impurity with intrinsic semiconductor, now this is called as extrinsic semiconductor. For example, doping of silicon with aluminium and germanium with phosphorus, etc. There are two types of doping: donor doping and acceptor doping. So as a result of donor doping, we obtain N-type silicon, and as acceptor doping, we get P-type. So what are donor or acceptor doping? Doping of semiconductor with pentavalent atom such as phosphorus or arsenic. And what is acceptor doping? Doping of semiconductor with trivalent atom, for example boron, aluminium. Let's see in detail. Phosphorus has 5 valence electron. Atomic number of phosphorus is 15, 2 in its first shell, 8 in its second shell, and 5 in its third shell. So there are 5 valence shell electron present in phosphorus. And due to the presence of this 5 electron, this is called as pentavalent. And in aluminium or boron, there are 3 valence electron, hence this is called as trivalent. Now, let's see the doping of silicon. Silicon with atomic number 14 with electronic configuration has 4 valence electron. So it is tetravalent. So there are 4 valence electrons shown with cross of silicon, and there are 5 electrons, valence electron of phosphorus, which are represented as blue dots. So when silicon is mixed with phosphorus, then 4 of the electrons of phosphorus, these form bond with silicon, because silicon can form 4 bonds. So there are many silicon and phosphorus atoms, so each silicon combine with 4 electron of phosphorus, and in each phosphorus there is a free electron which is not involved in bonding, and due to the presence of this free electron, this semiconductor acquire negative charge, hence this is called as N-type semiconductor. And when aluminium is mixed with silicon, then 4 of the electrons of silicon form bond with 3 of the electron of aluminium. Let's see. These are 3 valence electron of aluminium. This electron form bond with this silicon, this, and the 4th bond of silicon and aluminium contain hole. Let us see this bond. One of the electron of silicon form bond with aluminium. There is no electron present in this orbital. So if we see this bond, there is present a hole, and due to the presence of hole, it is said to be electron deficient, or said to contain the positive charge, hence this is called as P-type semiconductor. So what are the effects of presence of free electrons or presence of hole on the conduction of semiconductor? Let's see the bands in semiconductor. So this is pure semiconductor. It has 2 bands, valence band and conduction band. All the valence electrons are present in valence band. So when the electron excited from valence band to the conduction band, it needs 1.1 electron volt energy, and this is very high energy to excite the electron and to carry out the conduction of the semiconductor. Now After doping, after donor doping, what happened? Donor atom acquire this level between the valence and conduction band, and this is called as donor level. As free electron is present in donor level, then it is easily excited to the conduction band, and it only requires 0.01 electron volt energy, and this type of excitation is facilitated due to the doping of silicon with the phosphorus. And if we see the acceptor doping, due to the presence of hole, let's see p type, this is valence band, and this position or level is acquired by the acceptor atom, and this is called as acceptor level. Now the electron will jump from this level to the conduction band. So this level is present nearest to the valence band. And what is the energy gap difference? 0.01 electron volt between acceptor level and valence band. So in this type of semiconductor, it requires more energy to excite from acceptor level to the conduction band. It is due to the presence of hole in semiconductor. So these are the bands in semiconductor, and what these bands shows that due to the doping, excitation become easy as compared to the pure semiconductor. This is all about semiconductor, their types and their band conduction. Thank you very much.